kind of. Yeah.
So I spent a good deal of my life working last few years on specifications. The JSR 220 was EJB3 specification, and the Java Persistence API. I was co-lead on that. I also worked on the Java EE5 specification. So for those of you who've been using that, I hope that's been working out for you. I wrote a book called Pro EJB3, Java Persistence API, which is kind of the main JPA book on the market last year. So I think a couple other ones have joined it now, so there's some choice. I work for Oracle as an architect in the persistence area. I've been doing persistence most of my life, in some form or another. In fact, I'm one of the few people who actually did my grad work in persistence and then ended up working persistence. So it's kind of weird. I don't know how that worked out. So I get around. I want to see how many people here actually. I don't think anybody's used EJB3 yet, right?
Oh, since last Friday.
Oh, wow, you started it. Oh boy, you got a leg up on this then. What about JPA? Now, someone said they tried JPA.
A
little bit.
I have to admit though that it's all within our framework, so I haven't done it like from scratch.
Right.
So it's still for me to learn here.
Okay. Well, there's also whatever you use to be able to ask questions about more stuff, advanced questions. I can answer those. So the rest of you guys probably have used some framework that is proprietary in some way, be it Spring or Toplink or Hibernate or some proprietary API. I'm sure. So this is where I find out actually how many people plan on using it who haven't already used it. So those guys who haven't used it before, do you guys think that you're going to use it?
JPA. Yeah.
Check it out.
Yeah, probably JPA.
The other guys think maybe, probably not yet. No, you're not convinced. And the other rest of you probably think, nah, never. I'm just here because of this free beer. These are some of the basic questions that we kind of hope will answer throughout the evening. If at the end of this evening we don't know the answers to these and we've drunk too much beer or not cared. So some of the myths about EJB3 are that you need annotations. And this is actually not true. Annotations are a key part of EJB3 and JPA, but they're never required. We use annotations because it makes things easier, but you're not required to use any annotations ever. You can always use XML instead of annotations. Annotations are an option that we hope makes everybody's lives easier. And for the most part, I think this has been proven true, but in some cases, people still like XML and they're free to use that XML. Migration, just because you have EJB2 session beans somewhere doesn't mean that you can't actually use those in EJB3. EJB2 is completely portable to an EJB3 container, so you should be able to run those as they are inside of an EJB3 container. An EJB3 container is actually supposed to support EJB2 as well.
Supposed to, or I mean,
if it's compliant, it will. Yeah. Also, we did some work on EJB3 to make sure that you can migrate EJB2 beans toward EJB3. So you can migrate either the client side or the server side and change the components themselves into EJB2 components. So and you'll see what that means a little bit later. Vendors, basically, there's almost all the vendors except IBM. Actually, it doesn't have EJB3 support yet, but all the other ones do. IBM
not officially.
Not officially. I know they've been working on it for a while. I know the guys have been working on it.
Preview packs and things like that where you get support.
Yeah, but that's the kind of customers kind of want to wait sometimes for this sort of thing. So. And some people think, well, too late. EJB2 sucks so bad. Why should we even go? Everybody's turned off EJB now anyway. That's actually not been true either. We've seen people that abandoned EJB a long time ago and have seen what's in EJB now and go like, oh, I'm coming back. This looks like it's worth trying. So that's essentially what I'm going to show you. Yeah. EJB3, well, this is basically EJB. It's just this component. The technology is still the same. It solves the same problem. The problem it solves is reusable component server-side logic, right? Something you can take, bundle up, and deploy into some applications. And you hopefully even could take that and reuse that logic in some other way. So it's reusable, it's invocable, it's redeployable. You can usually, with some amount of effort, and that amount of effort to port from one server to another may differ according to the servers. But at any rate, the basic logic will be. It's just that the part that you have to port is usually configuration type stuff, not the actual logic. So the differences between EJB 2.1 and EJB 3 are actually quite dramatic. So when you put a chart up and look at the differences, you'll see that EJB 2 requires deployment descriptors. Lots and lots of them, right? It requires XML. Reams of XML, and EJB 3 actually just needs annotations or XML or both, and less of it, much, much less. You need a home interface for all of the EJBs that you had to develop. A home interface, and then one or two or more remote or local interfaces for every component. In EJB 3, you just need a business interface and the bean itself, and that's all. There's certain rules that you had to follow when you're defining your beans and your interfaces. Those rules are gone in EJB 3. You can have any class be a bean and any interface be an interface. In other words, they don't have to extend or implement anything. The lookups were rather annoying in EJB 2, where you had to do a Jindy lookup and then catch the name not found exception, and then get the home interface, and then do a create on the bean, and so on. And then finally, after a whole pile of code, then you could finally invoke a bean method. In EJB 3, all you do is you define your dependency upon the bean, and then you invoke it, just like that. So you'll see an example of how to do that. Metadata used to have to be long. We said that the XML deployment descriptors used to have to be big, long XML, EJB-jar XML files. And in EJB 3, if you want to use the EJB-jar XML file, you still can if you want to, or you can just use annotations. I'm going to show annotations because it's so much easier in slide form. The XML, still can be longer, because XML is by nature verbose. The problem with XML is you have to always define the context of the metadata that you're supplying. What does this metadata apply to? Whereas annotations, you're applying it to the artifact itself. So the context is itself there. You don't have to describe it. Whereas XML, it's a separate location here that has to define what this applies to, and that ends up being where most of the verbosity comes from, is saying what this applies to. But the idea is that if you do the usual kind of thing and are happy with the usual kinds of attributes, then you don't have to specify anything else. That if you're happy with the kind of usual behavior that you get, then you basically go along with it and you don't specify anything. You only should have to specify things if you want to do something different from the norm. Okay? Because most of the time there is a norm. 80 to 90% of the time people are all doing the same thing. They're all using a transaction attribute of required. They all want a transaction to do things. They all, kind of want to call session bean the same sort of way. And so, people always require the same metadata in the files, and you see that duplicated all the time. So what we said is, well, let's define some defaults, and if someone wants something other than those defaults, then that's fine, they can supply the metadata. But apart from that, they should have nothing. And, EJB 2, for those of you who've used it, how many people here have used EJB 2, by the way? Okay, only half of you. The other guys haven't even used it. You must have used it. Come on, global services? What?
Should have, but I haven't.
Never did, eh? Yeah, wow. And you
I haven't seen version 1.
Okay, so you did use version 1, though. Okay, that's pretty much the same thing then. And you never used it at all?
No, I used 1.
Oh, you did use 1. Okay, so you know EJB then. Even if you didn't use 2, 2 just added some more stuff. But it didn't really make it any easier, or just added more stuff to do.
It made it more complicated.
It made it more complicated in many ways.
Fair to say that EJB 2 was kind of written for the container perspective, but now EJB 3 looks like it's written for the coders to do what they need to do.
Yeah. Well, EJB 2 actually assumed an IDE all along. It never really assumed that you could kind of take Emacs and kind of code together some classes and then just go. You'd have to, have multiple windows for one thing, right? For all your interfaces and classes, and then your deployment descriptors and everything. And without an IDE, you just couldn't do it. It was just a nightmare.
You're not going to believe this, but I was once called in to support an application by a Dutch organization called TNO, which is quite a big scientific organization that's made an application for telecom. And when I got there, the guy hadn't used Emacs to do it. He literally used VI to do it.
Yeah,
He'd
VI.
written everything himself.
Yeah, well, sure. I mean,
Yeah, I've done that.
so we've all had to use VI for doing these kinds of things, but you know, it was never development. It's murder. It's murder, and so it was assumed that some ID would generate these things, but the tools actually didn't come.
Yeah, I think that's the thing. It's like, yeah, it's kind of assumes an IDE, but I think, well, it sounds like, you know, there are among us people that weren't doing it through an IDE.
Yeah.
And we're still doing it through effectively in text editor. You know, might have had IDE syntax highlighting and stuff, but it was just effectively still a syntax.
But there wasn't really the proper tooling to affect all of the things you needed.
We used Xdoclet to generate all of that.
Right.
Docklets.
That was the next round, right? When people realized, wait a second, we can't maintain this. They started using Xdoclet, which was a gen tool to allow this to happen. So in EJB 3, we kind of said, well, okay, there always will be somebody using a text editor to develop this. They should be allowed to. It should be possible. It shouldn't be such a big deal. So that's one of the premises. All right, now we go through actually trying this out. We want to create a session bean. These are the 5 steps to creating a session bean. First step is to create your local or remote interface. Oh, sorry, if I move around, you won't see me, will you?
No, that's fine.
Yeah, all right.
But you're right. If you
If I go way over here.
exactly.
Okay.
Where you're standing is excellent.
Okay. So the first step is to create your interface, and if you have a local and remote, then you create one of each. Right now, you can't use the same interface for both, but you could use a super interface that contains everything and just have 2 shallow interfaces. And the reason is because when you inject it, then you wouldn't know which one to use, the local or the remote version. And the container has to generate one or the other depending on whether it's local or remote. It has to generate a whole different thing. For locality and for remoteness, it's going to be a complete pass by value. So that's not. But anyway, we'll just go through it as if we're creating a local one and do our example. Second one is just to create the bean class itself. This is just the implementation. So this is just like you would program in Java, right? If you were creating an application and you had to talk to the guy beside you in the next cubicle, and he had some pieces of code that was going to be calling you, you'd say, okay, I'll give you an interface. You design the interface up, and he'd write to that interface, and you put the implementation together underneath it. And your implementation would implement the interface. Makes sense. Well, the next thing you do, now this is the EJB part, is you add some metadata. Say this is an EJB, this is a session bean. Finally, you package the stuff up in some kind of jar, right? And we generally think of that as an EJB jar, but it's just a regular jar file, right? And you sit back and you hope it works. So the sample application that we're going to look at is this web tier, which we won't really kind of look at. We'll just assume that some web tier is there. So that just will distract us from the problem at hand. The business interface that we're going to have is going to be a simple account operations, and it's going to allow some simple operations on an account, and the bean implementation itself. We're going to have a simple account entity, which will represent a database row in a database table. Okay, so it's a simple thing, but it gives us a chance to see how to put this application together. Here's our business interface. There's nothing special about this interface. It's just a regular interface. So we'll call it a business interface. Our dinner might come earlier than we thought.
No, it'll.
Yeah, that's okay. Whenever it comes, it comes. So these are the 5 operations we're going to put on our interface. We're going to create an account, get a balance, deposit, withdraw, close account, and we're going to, on the create account one, we're going to accept the customer name and return an integer, which will be the account number. So the account number is going to be generated for us. You can pass in the account number later on and get the balance, and return the balance. Pass the account number and an amount to deposit, and return the balance. Withdraw similarly, and then close it, return the balance that was left in our account. Okay. The bean class, step 2. Well, all we do is we create a class implementation, we implement our business interface. Right? This is just regular Java. We're not doing nothing so far should be weird or different. And then we implement all of our methods, and we'll show the implementations later. Now, this is the first step that's EJB, really. We have to add some metadata to show that this is an EJB session bean. It's a stateless session bean, so what we've done is we imported this javax.ejb.stateless annotation class. And then we annotated the class with that stateless. All right, that's all we've done. And that's all we have to do. Right now, when we put this thing in the server, it's now a session bean. A single annotation tells the container that we have a session bean. And the only thing left to do then is package it up. So we put the two classes, the interface and our implementation class, into this jar, and we give it to the server. You deploy it. That's all we got to do. We have an EJB session bean right there. Can it be any easier than adding a single annotation to our class? I don't think so. See, that's how easy it is. I want to enjoy it because we did so much work in putting the session bean together. Well, we didn't do any work. We just created a simple class and interface. We implemented the interface like we would anyway, and then we added some metadata. And the metadata we added was an annotation. We could have added a simple XML file that only really had one entry and said this is a session bean, right? So it would be, you know, a session bean, and then it would say this the name, or the name is optional now, so it would just have to be the class, right? And then the business interface. That's all it would have to be. Well, what if we wanted, by default, we actually got a local interface. And that's actually what most people tend to want. Hardly anybody these days kind of goes from the client and talks to a session bean remotely. Sometimes. If you're doing interop or something like that, you might want it for sure. But at any rate, let's say we do want a remote access interface. So in this case, we'd have to put a remote annotation on either the bean or the interface. If it's on the interface, that's enough. It just tells us this is a remote interface, so the container does the right thing, it generates stuff so that it passes by value and goes across RMI to do it. Or we could put it on the bean and say this is the interface. This interface here is actually remote. Treat that as remote and do the same thing. So sometimes you want to put it on the bean, sometimes you want to put it on the interface. Depends on, you know, which one you like to do. But that's pretty much it. And if you recall back in the old days with EJB, if you had a remote interface, what did you have to do? You had to have remote exception thrown all over the place. And then you had to cache it on the client because all those methods now through remote exception. We don't have to do that anymore. So you don't have to catch any exception, and you don't have to throw them in the methods. This interface will be made remote simply by putting @remote, and the client can be a remote client. It doesn't have to catch any remote exceptions. You say, well, how is that possible? It's going over RMI. Well, it's possible because the container is doing the work for you. It's going to wrap those remote exceptions and throw them in a runtime EJB exception. Because the thing is, here's the thing with RMI exceptions. You know, you have to catch them, but there's never anything you can do about it. It's not like, oh, okay, well, I'll just fix that. Well, no, you can't fix it. You just basically throw an exception to the user and say, well, things failed here, you know. So you may as well just have an unchecked exception, a runtime exception, and not bother catching it. You still can catch it if you want to, and you think you can do something about it. You're just catching a runtime exception instead of being forced to catch a checked exception. So that's what the container will do. It'll wrap it in a runtime exception, and then, you know, it'll do the work, and you don't have to. Okay, here's another thing that was really broken in EJB 2.1. Lifecycle methods. Now, you used to have to implement a session bean interface back in EJB 2. And these had a bunch of lifecycle methods on them, which you basically wrote, and then, you know, put empty brackets in because you never used them for anything. So you have all this empty code that was just cheese in your classes. Well, why should you have to do that if you don't even need them? So in EJB 3, lifecycle methods are optional. You don't have to put them in. And remember, you don't have to implement the specific EJB interface. It's just your own interface, so you're not forced to put them in. Well, how do you indicate something's a lifecycle method? Well, the way you indicate it is you specify some metadata that says this is a lifecycle method. That's all. You have some, and you indicate that they are them. And the lifecycle methods that are possible are basically a stateful session bean, post-construct, and pre-destroy. That's all a stateful session bean really has. So post-construct says after it's been created, you throw it in the pool, just initialize it with a post-construct callback. And this gives you a chance to initialize something. Pre-destroy says, oh, okay, I'm just about to get rid of this, throw it out, do a pre-destroy, call that. If there is one, then it'll get invoked. Stateful session beans can be passivated, so they get these two additional ones. Message-driven beans, of course, only use the first two as well. Let's see an example of using lifecycle methods. We have our stateless session bean. That's stateless. Now we're going to have an audit on here. This is our own property, our own resource. So we're going to initialize it when the session bean gets created. And we initialize it with a post construct. So we create a method, and it's just a method. And we're naming it init audit session. And we're annotating with post construct. So by annotating this with post construct, the container will see that and say, oh, okay, I better call that when this bean gets constructed. Now, how many people here have used Spring? Okay, so this is nothing new for Spring users, right? You have lifecycle callbacks in Spring for the Spring beans. And this is the only thing nice about this is that it doesn't force you to use any particular method name. You can just call whatever you want and just annotate it. So in this case, we're going to create, using the factory, create an audit session and assign it to this audit variable. And then in pre-destroy to before it, so we don't leak resources, we're going to actually close our audit. And everything in the middle is going to use this audit and audit what happens. Call something on our audit string and go. So by using these lifecycle callbacks, I can initialize my own resources and clean up afterwards, managing them according to what I know needs to be done. Okay? It gives me a level above the container for my own resources.
Are there any restrictions on you have more than one lifecycle method? Or more than one method associated to a lifecycle event?
Yeah, you can't have more than one in a class. You wouldn't need to. You could always just call the other method or whatever from that class.
So you've actually got some control.
But you could actually have classes above you in the inheritance hierarchy and annotate those and have multiple levels of constructing, and then they'll be called in the right order. So they're actually, this can get quite complex when you have multiple inheritance hierarchies. But it still works. Yeah. Okay, so the next thing is if you, how many people here have used aspect-oriented programming, or not even used it, but know about it, AOP? Okay, most of you have used some sort of AOP or know about what aspects are about. In a sense, aspects is really just a way of thinking about pieces of your logic that kind of go together. This separation of concerns is the common term around aspect-oriented programming, where you say, all of the logic to do a particular job can go over here. And the prototypical separation of concern for AOP is logging. That's the one that we all like to talk about, AOP. Because everybody's got logging in every method. And it might log something like, for me, I actually like to have a debug method. At the beginning, the entry and exit of a method. At the beginning, I'd like to say I've gone to this method, and then at the end you say I'm exiting this method. Well, this generally means that you got to stick a log statement at the beginning and end of every method. But in a AOP world, you could say, don't put any of these log statements in any of your methods. You could say over here somewhere, say for all the methods over there, put this statement at the beginning and this thing at the end. Execute some code. And so this is like a logging aspect that says, do all my logging this way. And it applies to a bunch of code over here. So it's not actually co-located with your business logic, but it describes or is overlaid on top of your business logic. And then the aspect compiler is responsible for kind of putting that in, putting that code and reading it into your other at the various join points. So interceptors are kind of an AOP-like construct. They give you some AOP functionality, the ability to intercept business methods. So if I want to do something before a business method gets executed, but it's not in the business method itself, it's somewhere else, I can make that an interceptor. And that will then get invoked. The container will invoke me before it invokes the business method. This allows us to do some very powerful things that we'll see. We call this a round advice. And advice is just the kind of code that gets executed. The round advice means that this will be executed before the business method gets invoked. And then I'm in charge of invoking the business method myself. And then I can handle the result of that business method as well. So I get to execute around it, kind of enveloping around the actual business method call. And that's kind of powerful because I can do things before and after. The kind of things I can do is I can actually change parameters, for example, going into business method. If a business method gets called on my interface, I get called first, and I get all the context. So I get the parameters, the name of the method, and I can take the parameters change them around a little bit, and then say, okay, now call the business method. And then the business method returns, and I can say, what's it got returned from this business method? Oh, I can change that around, and then pass it back out. So this gives you a lot of power in your business methods. And it means you don't have to co-locate all that stuff in the same session bean. You can actually define this interceptor that goes around and envelopes this call. I can even veto the operation at all, entirely. So if everything wasn't quite right, if I'm maybe auditing the business methods and I say, oh, he returned some balance. Oh, he's not allowed to do that. Okay. Don't return that result at all, throw an exception. So the business method, basically, result never gets returned. So you can do things like that.
And then there's also a comment you can chain them. So you can kind of say, use this interceptor followed by that interceptor.
Yeah, so you can chain interceptors. The second thing says, because there's this global context that gets passed, not global, but global in the call, it gets passed from one interceptor to the next. If I define multiple interceptors into a chain, then I can pass contextual information from one interceptor to the other ones down the road. And any downstream interceptor will then get all of the contextual information that I've passed to it, and maybe use that in its own decision-making process. So let's say that my first interceptor is a security interceptor, and the security interceptor looks up something and says, oh, okay, based on the rules that I've read in, this is what's allowed, and it puts this in this context. And then other interceptors down the road that are more fine-grained might look at what's allowed and then make decisions in their own logic based on what they found in the context. So you can do that. All the slide says really is that you can define interceptors at different levels of granularity. You can scope them at a method. So you can define any method to be intercepted. Only that method. You can define it to be an entire class. So all the methods in any in this particular bean rather are going to be intercepted by this interceptor. Or you can just say, I want all the all the session beans in this EJB module and all the methods on those session beans to be intercepted by this interceptor. So right there, that's a good debugging interceptor, right? Just, I want everything to go through this method before it gets called. So that's kind of the level that you can decide.
Is there much of a performance penalty for doing that?
There actually isn't. Well, it depends on the implementation. I can't say that there isn't. There can be. I know that when we did our implementation, there isn't. We did it very, we optimized the heck out of this thing, and we actually are faster now than we were before. We're way faster, because you can actually use interceptors for system-level code. And so what we do is we have some system-level interceptors that do things like security and do the transactions. We reorganized, because we had the interceptors, we thought, well, we may as well use these internally as well. And so we have some special ones that we'll use, and it ends up being actually quite a lot faster. We can make empty calls in a matter of microseconds now, empty session bean calls.
When you say we use it, you mean the Oracle?
The Oracle implementation, yeah. Yeah, that's as fast an implementation as I can see actually being possible now, because if there's nothing there, then basically the interceptor can just not be put in the chain. So this code that you're not even calling. But anyway, so here's an example of an interceptor. It's a profiler. Let's say we want to see how long the methods are taking. So I define a class, any class at all. I'm going to call it profiler. I define a method. It's any method at all, except that it has to have a certain signature. It has to return an object. It has to accept an invocation context as an argument. All right, that's the one parameter that you have to have, and you can name it anything you want. So around invoke is the annotation that I put on this to show that it's an interception method. My interceptor method is going to be invoked. So all the business methods, before they get invoked, this method is going to be invoked first. Okay, so what does it do? Well, here, just finding the time, sort of starts a timer, and then it does invocation.proceed. And this is the invocation context that got passed. Proceed means go ahead and call the business method. If I don't call that, then the business method will never happen. It won't happen. It's basically me vetoing the business method. So if I want to stop all business methods from happening, I can put an interceptor in there that doesn't call invocation proceed, and it's a stub. Okay.
So that context, is that that's provided by the container, like
Yeah.
by default on everything.
Yeah.
You just get that, and then it sort of delegates down in the proceeding.
Exactly.
To whatever interface is on
The container is responsible for filling this indication context on the business method. And it gives you can look at parameters, you can look at the method name that's being called of the business method that you're intercepting. It gives you a global context, an indication context that you can, a global context for this indication. Anyway, so once you call proceed, then it's going to call the business method. All right? And now I'm going to return that result because this business method probably has, or might have at least, some result. If it's void, well, it just returns nothing, so I just return it. But here, I know that I'm returning something, so I'm going to return the result of that. If I don't return the result of this, then the result doesn't get returned. Right? I have to remember to return it. If that session bean method has a return value, I'm the one that has to return it, because I called it. Now, if there were more interceptors, the indication proceed says go on to the next interceptor in the chain. And then it then in turn better call indication proceed to call the business method or the next interceptor. Okay, so it goes down this chain of interceptors until the last one in the chain calls proceed and it calls the business method. And then it gets the result and it does something and then it unwinds back through each interceptor until you get to the end or the beginning. You think of it that way. And in my case, I'm saying finally, because I want to record the value of the timer whether an exception was raised or not. So it's going to time it even if there was a problem in the call. And I'm just going to find out how long it was, how much time has elapsed. I'm going to get the method that we invoked, and I'm going to log it. I'm going to log something saying this is the method that was called, this is how long it took. So, I mean, I've only got, a half a dozen lines of code there, and I add this interceptor, and now I've been able to time every single method without changing a single method in the build. That's very, very handy.
So that interceptor has to throw exception too, I would have thought.
It does. It throws an exception here. Because if there's an exception thrown here, you have to, otherwise it's a compile problem. Because you don't know what this business method throws. So you have to throw exception here.
How do you modify the return?
So I would hold on to the return instead of returning here. I would hold on to it.
Right.
I can look at it, play around with it, and then return
There's no
it.
special methods needed for it.
Yeah, there's nothing special. I'm just calling it, so it's just like I've got a first crack at the can to be able to change it and do whatever I want with it. I could return one from every business method if I wanted to. 43, 43,
42.
42. That was the old. So how do I make this interceptor get called? This is how I do it. I put an interceptor's annotation on my bean class. So this is one way to do it, I should say. If I want it to happen for all the methods of this bean class, I put it on this bean class. If I want it to have on one method, then I put it just on that method. Now this assumes that I'm okay modifying my bean class to put the interceptor on it. If I'm not, then I'd probably use an XML entry to say, oh, apply this to the bean class. That would mean I would get away from having to change the bean class itself, which is probably more realistic for interceptors. Chances are you don't want to change the bean class, otherwise you're kind of back to where you were and having to put log statements inside the bean. But it's still a little bit cleaner even doing this. So there's an XML in the EJB jar XML file. You can put an interceptor class, and that'll apply to all the beans in that jar.
So that interceptor there on the class means every method?
Yeah, on the class means every method of this class. Any questions about interceptors?
How to do the order? Like if you've got multiple.
I'm sorry?
If you've got multiple interceptors.
Yeah, so you just put a comma and then more classes.
And it
An
pays
array.
attention to the order that they're.
And exactly, it'll take the order of the way in the order that you've defined them, and chain them in that order.
Okay.
Yeah. So that's, I mean, this is not a full AOP, right? This is just like a slice of what AOP can do, but it's enough actually to do a lot of what people want to do in AOP. So it gives you just enough to do, I don't know what percentile, but it's so without having to define a whole AOP point cut language, which is what you get with a full-blown thing. And if you need more than this, of course, you could use a full-blown AOP aspect J or something. Okay, dependency injection. Most people pretty much know what this is at this stage. If you use Spring or any other AOP container or dependency injection container, essentially this just means that you, as an application, define what your dependency is, and then the container is responsible for filling that dependency in. And you just have to say what it is that you want filled in, or have some rule for it being defined and filled in for you. So in Java EE, we have a defined set of resources that say there's about less than a dozen resources that you could use to actually inject, and everything else is outside the spec. So a full-blown DI container would be able to inject virtually anything. If you're using Spring, you could inject this any old Spring bean, and it could define anything else, right? And you could, you know, that's way more flexibility. But this is sort of what most people need in a Java EE environment. They kind of use Java EE resources. So this is kind of the lines that were drawn.
So are you talking about you inject a data source or inject
exactly. Yeah, a user transaction or, you know,
session.
a queue factory or something. Okay, so here's how you actually inject it. You've got your data session bean, and let's say in this case we're actually wanting to inject a data source. So we annotate with that resource. Using annotation makes complete sense here, because we actually want, and assume in this code, this data source to be injected. If the data source isn't injected, then the code breaks, because we're not going to try to look it up or get it. We're going to assume that it's there. So in create account, we assume the connection of the data source is there and get a connection off of it. So account data source dot get connection. We haven't ever initialized the account data source. We assume that it's the right one and that it's been put there inside account DS. Okay. So an annotation says, yes, please inject this right here. And it'll look for an account DS in global Jindy or whatever, right? According to whatever the server does. And so you would have had to have defined a data source in your application server somewhere, in whatever server you have according to the server rules. So in a data sources.xml file or something like that, and then define that that was some global Jindy location called DS. And then it would just get injected from it. There's also some attributes on this resource annotation that you could use to further specify this. And you know, there's more to it as well. You can actually say where in Jindy you want it to be, because by injecting this, you're actually causing this resource to be imported into your Jindy environment space. Okay? And you could say where in the Jindy space you want that to be imported. So if you wanted to dynamically look it up later on in Jindy, then it's there and you know where. But most of the time you don't even care. You don't really care that it's importing into JNDI. All right.
A bit earlier than expected.
Yeah,
Perfect.
Our culture break. There you go.
Yeah. So this is our breakdown.
Excellent time.
Yeah, we'll try changing anything. Okay, so move on to the JPA part. So now we know how to write a session bean. Let's try to put the persistence part into the other part of the mix. You back on again?
Yep, we're on.
All right. So here's just an update, kind of an overview of JPA. It was released over a year ago now in Java 1, 2006. It's kind of a merger of expertise from the major players out in the OR space. It's primarily an OR mapping API, for mapping Java to the relational database. It has a really good story for integration with the Java EE container. It's really, really easy to use when you use it in that environment. On the other hand, if you don't use it in that environment, you can still do so. It is not as convenient, but it's still fully functional. And we'll show quickly how to use it outside of the EE environment in a regular Java SE. And the other thing that we added in JPA 1 was the ability to plug in different JPA providers into a container. So if a container is fully compliant, and a JPA provider is fully compliant as a JPA implementation, then you can actually mix and match different EJB3 containers with different JPA providers. This service provider interface allows that to happen.
Does that mean you can actually have more than one JPA provider within the same container?
Absolutely, yeah. You can have different persistence units managed by different providers. Okay, so we say that they're entities and not entity beings, because entities are just a simple, kind of the traditional definition of an entity. In the entity relational, the ER model, then you kind of view an entity as sort of just an object with some state. And in this case, the state is just representative of a database row. This is typically what people want. There really aren't that many requirements. The fields should be non-final. That's mostly there to allow different kinds of implementations, particularly those who want to do more code generation-based implementations. You can do that. A lot of the implementations out there actually allow final fields, just because there's nothing stopping them from allowing them to be final. The NOR constructor is just so that they can create the entities. Serializability is not a requirement. You don't have to make it serializable. If you're using a remote interface, then it should be serializable because you want to serialize it. But if you're not, if it's a local interface, then you wouldn't even need it to be serializable. And of course, you don't need to have business interfaces. You can just access the entity and invoke it as it is. So let's go through the 5 steps of creating an entity. First step is to create a class that represents the data. So, I mean, there's even generation tools to generate the class. If you have a database that you're already using, you can generate the Java class. But most of the time, you just want to create one yourself, and then you add the metadata to say this is an entity. After that is the OR mapping metadata, which is sort of a different layer. It says how does this go to the database table. The configuration is usually quite brief. It just says what classes are persistent in an SE world, or in an EU world it says where am I going to write and read this stuff from? And where's the data source? That's pretty much it. And then package it up. There's lots of flexibility in packaging. You can package it up as part of an EJB jar, which is what we're going to do in this example, because we're using this with a session bean. But if you wanted to share a persistence unit across multiple EJB jars, or just to the servlet inside a WAR file, and you can package it up in a separate jar and put it in as a module inside of the application of its own. Okay, in just a persistence archive. So there's actually lots more you can do, but we're just going to do the simplest case, whereas you're just going to actually take a session bean, talk to a persistence persistent account, and package the persistence artifacts right in the jar. So part 1 is creating a class. And in this case, you see a simple class with an ID, a customer name, and a balance, and then any other stuff that you might want. And there's nothing really special about this class. It's just an account. The second step is to add the metadata to make it an account, or to make it an entity. And the Java persistence classes are all the annotations, and the entity is the annotation that we're using here to indicate. That's all I have to do to indicate an entity, is to add the entity annotation to the class.
Do any toolings allow like the annotation and the imports to kind of factor together?
Oh, I mean, any IDE, if you just put add entity and then you click a set of key sequences, Eclipse will have control shift M, I think it is, for Eclipse. So it'll basically most IDEs will just create the import definitions that you need. So this is the OR mapping metadata. The OR mapping metadata here is the ID to say what is the primary key field. And that's the required one. You must have the ID to say where the primary key is. The generated value is an additional one that we're using because we want the ID, the primary key, to be generated for us. All right, we're not going to create one when we create an entity. Remember our account. We're going to pass in a customer name and return the account number. So we're going to let the account number be generated for us, and then we'll return it. So generate value says the persistence engine should generate that account number. It's going to generate the primary key for you. And we're not telling it how to generate the primary key. We're just saying generate one. And it'll choose whatever strategy it feels like to generate it. If we really cared, if we were specific about our needs, then we could indicate the strategy. And there's a few strategies you can choose. You can choose a table in the database. You can choose a sequence, a database sequence, or an identity column to generate these.
Does the ID have to be numeric?
It can be a string. It can be a date. The other thing is we see a column here, and it says we're going to actually use the column named cust for cust name. Okay, the other ones, I didn't put anything on them because I'm going to let the defaults ride. And the default is just to use the name of the attribute as the name of the column. Same goes for the class name. The count is going to be used for the table name, the unqualified class name. And so I haven't specified what table to even go to. I'm just letting the default table name go. So I haven't put too much on here. In this case, I've only put a couple of, 2 or 3 extra annotations for the mapping metadata.
I was real worried about it, and I thought,
Now, this is my persistence unit configuration. So I've kind of grayed out the extra schema stuff, but there is some schema stuff that you put in. I think that's even more than you need. But the persistence unit has to have a name. That's really the main thing you have to have. And you can choose the name, whatever name you want. This is just to indicate this persistence unit, this configuration. And then you say the data source, and this is the JNDI name, where the data source will be found in the container. So this is where the persistence unit is going to find the data source. It's going to look it up in JNDI under this name. Okay? And the way you package it up, you have your jar already with the bean and the interface. You put the entity and the persistence XML file that we just created inside the same EJB jar. That's all you got to do. Those 2 classes, those 2 files. You deploy it in your server, and now you got persistence. Okay? Every EJB3 container is going to have a JPA provider already there by default. Okay? If it's BEA, it's going to have Codo. If it's JBoss, it's going to have Hibernate as a default. If it's Oracle C4J, it's going to have Topper. So you're going to have a default there. If you want to use a different one other than the default, then you can change your persistence XML file back here and specify a provider name. And that'll use the provider that you specify in there and invoke that to manage all the objects. And invoke into that persistence provider implementation instead of the default one.
Has anyone implemented any providers yet that use anything other than a relational database?
No, this is only defined to use relational databases.
Okay.
So the whole API is really geared around relational databases. If you want to use XML, there's a JAX-B API that allows you to map to XML. And what's that?
Just like how easy it is.
And you tidy up and it stays tidy.
So, I mean, that was kind of a basic class, right? There wasn't a lot to that. That was a pretty simple application, though. You can obviously do a lot more, and in most applications, of course, you will. But those were the basics. That was really all there was to it. Now we're going to kind of go in a little more detail about JPA. And in order to do that, we have to understand the basic notion of something called a persistence context. Persistence context is an abstraction. It is not really part of the API. And a persistence context is logically just a big hash set of all of the managed instances at any given time. So it's keyed by the primary key of the entity and the type, and then the values are the entities themselves. So you can think of them as really a hash table that has a double key, its type and its primary key. And the persistence context will only ever have one instance of a given type with a given primary key in it. All right? So everything that's in that hash set, everything that's in this persistence context is, we call managed. It's known. Everything that's not in there, but that exists in the database, if you have an entity sitting outside the persistence context, but there's a row in the database that corresponds to the primary key of this instance, then we call that object detached. Right? And as soon as the persistence context is closed, then every object in that persistence context becomes detached. There's no more persistence context holding on to it. It becomes detached from any persistence context. It has persistence representation in the database, but it is no longer being managed by any persistence provider.
So what does detached actually mean?
It means that you have an instance of the entity class,
Yeah.
and there is a corresponding row in the database with the same primary key.
Yeah.
But this persistence, this instance of the entity is not in any persistence context. It's not managed. No persistence context. There's no those logical hash map things that points to it.
So if you
no
do something with the
really
object,
Pardon?
not connected together anymore.
It may have other objects hanging off of it, but they are also detached.
and so if you do something to that object, it doesn't get reflected.
It doesn't
in
get
the
reflected in the database, exactly. So if it's not managed, then anything you do to that object is not going to be reflected in the database at all, because it's not managed. Nobody knows about it. The persistence engine can't do anything to it or with it. This is just a diagrammatic way of showing the same thing. It says these boxes would be objects and these words would be references. Then the application code has an entity manager instance which points to a persistence context.
Andrew was so funny.
And it also may have some entities
God's own country.
it's referencing that exist in that persistence context.
Bloody
And there's another one here that may have gotten pulled in through a query, but that's not being referenced right now.
Yep, exactly.
And then it may have created another instance
And Headland
in
is
here that is
always
actually not in the persistence context,
It's just disgusting.
but it sits outside as a detached object.
Anyway, he thinks it's God's own country. It's
So,
so funny. They
this is
have
just kind of an idea
well,
of
there's
having
roads,
instances
there's
both
laws,
managed
which
and
they
detached.
call PHP.
This object may be detached
And then
or it may
growing
be
trees
a
and
new
trees
object. In
and
other words, I may have just
trees
created
around
this out of the blue,
chainsaw.
and it may or may not even have an ID in it. And so it may not exist in the data store here.
So you can pick Andrew's house.
In which
and
case it's
drive
not even
along
detached because there's no persistent representation of that state.
Unbelievable. And then he's got these houses.
Now the entity manager is really the thing that you do see. That's the API part. That's the object that you as a client can use to get your hands on stuff. And it's basically where most of the JPA API sits. Okay? So this actually points to, as we saw in the last figure, it points to a persistence context internally. You can think of it as a persistence context that belongs to the entity manager. The different dimensions of these kind of create a number of different combinations of persistence context and entity managers based on these facets. The transactional one, there's two different kinds of transactions. There's lifecycle variable where you can have a container managed or application managed, and the scope being that the persistence context lasts the transaction or it lasts beyond the transaction across multiple transactions. So these kind of allow for variables having different kinds of persistence context and different kinds of entity managers. The transaction scoped one, as I say, basically is a default one in the container that just says that my persistence context is going to last for the duration of this transaction. This is a JTA transaction we're talking about here. So it's in a container transaction, and all the entities that get read in during that transaction will get put in the persistence context. So they'll become managed. And as soon as the transaction commits or rolls back, then everything gets cut from there. The persistence context gets closed, transaction's over, everything's detached. Extended scope, on the other hand, says entities will stay managed even across transactions. Transactions can come, they can go, but your persistence context stays there. So everything that gets loaded in stays there. And if you keep loading more stuff in, doing more transactions, the persistence context gets fuller and fuller and fuller. So there's some danger in actually having one of these big persistence contexts because it can grow and consume, all of your entities, which may be what you want. Maybe you want to cache all your entities. Who knows? but you want to probably be careful if you are,
And it's in the middle of nowhere.
that you're doing it on purpose and not by accident.
All the houses are built.
The transaction types are the container transaction, and this is the kind of the way that the default transaction type when you're running within a container, in a Java EJB3 container. You can actually define an extended persistence context with JTA transactions in a stateful session bean. This just means that your transactions will come and go. Your stateful session bean can have multiple methods invoked on it across multiple transactions, and the persistence context stays there and keeps all the previous entities that it had loaded in. So it just keeps living. Whereas if a resource local entity manager is happening, then that's always going to be an extended persistence context. That means that there's a local transaction. There's not a JTA transaction. It's just a local one that the entity manager is managing, or the entity manager is managing the transactional resource, which is usually a JDBC connection. And it's actually nothing to do with any JTA transaction. JTA transaction may even be present, but it's not associated with that JTA transaction. It's a whole different transaction. It's a local JDBC. Sorry. There could be a JTA transaction, but the JDBC transaction is not part of that JTA transaction.
So why does that always have an extended? So extended persistence context was the thing where
That goes across transactions.
goes across
Yes.
transactions. So if it's only associated with a local JDBC transaction, that transaction closes. You still keep your persistence context, so you can't get rid of it if you're just using JDBC.
You can. There is an explicit operation to clear the persistence context, but it's manual.
Okay.
It doesn't disappear on its own at the end of transaction. It's extended so that you have to manually clear it if you want it cleared.
So why is that?
Well, because there is no management of that entity manager. In the JTA case, it's container managed. The container is managing the lifecycle. So let's look right here, because that's what we're talking about. The container closes and opens the persistence context on its own. So when the JTA transaction completes, it knows it can go ahead and close the persistence context.
So with JDBC transactions, you're managing your own transactions. So
You're managing your own transaction, so you're going to manage the persistence context as well. Exactly. Okay? So you can't have a container managed one with a JDBC transaction. It's always got to be a JTA transaction. That's the way the container can do the management. Now the thing you get for free is this propagation, which means that you know how you can use session beans and other things which propagate the JTA transaction. You can start a JTA transaction in a servlet, for example, and then call session bean, mark it required, and the transaction will be the same transaction, or market supports, I should say. So you can actually propagate transactions and allow that transaction to be accessed across multiple methods. But
your persistence context will be the same.
the nice thing about this is the persistence context will also get propagated along that transaction. So anywhere that transaction is, the persistence context will be in the container case. So it kind of makes sense when using the container for it to follow all the container rules. It just works out. And that's kind of what makes it easier to use. You don't have to pass things along or try to manage all this. The container does all the management for you. The other thing is that entity managers are much easier to obtain. You can just inject them as a J2E resource. Right? So just like all these other resources that you're able to inject, an entity manager is another one. So you just say at resource, or another in persistence, in the entity manager case, it's called at persistence context. It happens to be a different annotation because we have a couple other things that have to be specified. In particular, the unit name for the persistence context. Which persistence unit do you want? Which configuration of stuff do you want for this entity manager? So that's why it's a different annotation. The application manager, on the other hand, is quite manual. You as the application have to create it. You obtain the entity manager yourself. You say create entity manager from the factory, and then you have to close it when you're done with it. And you have this extended persistence context that just keeps growing, and if you don't, follow that, then you might kind of grow out of control. Usually, you'll kind of use it, and then close it again, and then you're done with it. So let's see how you use this container managed persistence context. Here we are back in our session bean, our account session bean. In this case, we want to inject an entity manager. because we want to write out our account. We have a create account method, so we want to create a new account, and we want to use an entity manager. Well, this is how we do it. We create an entity manager here simply by injecting it. That's all we have to do. From now on in this method, we can just invoke the entity manager. It's there for us. This is assuming that the persistence context, or the entity manager, there's only one persistence unit. I'm just defaulting it. In the application managed case, I'd actually have to inject a factory here. So this is an entity manager factory, and in create account, I have to say the factory create entity manager. Then I can invoke on it, and then I would have to close it, because I'm managing the entity manager explicitly. So I can still do some injecting here by injecting the factory, because I'm in a container, but the application is doing its own management of the entity manager. We call it application managed entity manager. It turns out if we have a factory, however we got this factory, we can create an entity manager. So if we're in a Java SE environment and we found a way to get a factory, we can do the same thing. And we'll see how to do that later. So the main operations are these. The persist is just the creating a thing. Removing is deleting a thing. Refreshing is just causing synchronization from the database into memory. Taking state that exists in the database to refresh the memory with that. The merge allows us to take detached instances and record that state to a managed instance so that it gets written into the database. Find is a primary key query, simple and easy. And these three methods here are query factory methods that allow us to create query objects, which we can then subsequently execute. And lastly, flush is like the opposite of refresh. It does synchronization with the database, but from memory to the database. Okay?
Is the flush and merge different?
Pardon?
How flush and merge different?
Merge says synchronize the state of a detached object with the state of a persistence context. It says take the persistence context and make this entity state be in that persistence context. Flush says take the state in the persistence context, already there, and make it in the database. And then refresh is take the state in the database and make that reflective in the persistence context object. So when would you use any of these? To refresh, you'd use if you think that someone's changed something in the database since you've read it in. If you think there's been a change to some state in the database of your object, and you don't have those changes, then you do a refresh. Pulls it into the database. Flush says, I've got some changes in memory that I want written to the database right now. I want to make sure they get written in the database right now so that I can do a query or something like that, and then find the results of this. And merge says, I've got this other object over here, which my client has changed, and I want to make sure these changes go to the database. So I merge these into a persistence context, where they can then get reflected in the database at the transaction commit time.
So if I get an entity by find by its primary key,
yes,
and I change one of the use a setter to change one of the properties, do I need to merge or flush it? You don't need to.
It's merged. It's managed already.
Okay.
So you only need to use merge if it's detached, if it's not in a persistence context.
But if you
find or do any operation on the entity manager to get the data, then everything you're getting is managed. It's part of the persistence context.
What set and it's done.
It'll just work.
Okay.
But if you do a find, you grab it, you set some stuff, and then you use the name query. Isn't the name query actually executing SQL? So if you don't flush,
exactly,
then it's not back in the database for the query to find it.
Yeah. So if you execute a query to the database, then you may have changes in your persistence context which haven't yet been flushed to the database. So you may want to flush manually. It turns out that what we have as a default is whenever you execute a query, we do a flush underneath the covers to cause those changes to be flushed out. You can change that default so that if you're executing queries that don't actually care about changed data in your persistence context, then you don't have to flush it all out for nothing and cause database writes without having a real reason to do it.
And if you want to deliberately detach, you close.
Yeah, you can't get a detached object from a managed object. You can't just simply say, I want to detach this. Because why would you want to do that?
If you've got some kind of long-running client gizmo thing. You don't want to keep a transaction open. You blah blah.
Oh yeah, you can send an entity across.
Yeah.
As soon as it leaves the VM, of course, it's detached, right? Because the thing you got serialized is now detached. There's only once you lose object identity, and you no longer have the managed object, you get a new identity, a new object that's now detached. So as soon as you serialize once, you have a detached object.
So when does if you can't, so if you've got a reference to an object and then you close your entity manager, what happens? What's that object?
Detached.
So it is so you could do that.
Well, you could, but I'm assuming you'd want to keep your persistence context open.
Yeah.
But
Okay.
yeah.
Yeah, all right.
Closing a persistence context is always going to detach everything.
Yes.
Yeah. Let's see how we can use these methods. If we want to persist an entity, then we construct a new instance just by using new, and then it becomes managed as soon as we persist it. So here's our create account method. We now get to implementing our methods in our session bean. Our session bean create account method is going to take the customer name, remember, and return the primary key that gets generated. So we say new account, right? That's all. New account. Passing in the customer name. The only thing different we have to do is say persist to that account. That account becomes managed. Okay, the account that we just created up here is now managed account. And it's going to be written to the database when the transaction's persisted, when the transaction's committed. And then we also said we're going to return the ID from the account. But somehow that ID is being created for us. Well, there's a problem here. That we don't necessarily know that ID has been created yet. Because we didn't say how the IDs were being created. Well, what happens if that ID is being created through an identity column? Well, then the ID won't be created until the object has been persisted and written to the database. But that doesn't usually happen until the transaction commits. And when's our transaction committing? Well, the transaction is committing at the end of the method because this is a session bean. And a session bean is required by default. So it's going to create a container transaction when you enter the method and commit it when you leave the method. So when you leave the method, then the commit is going to happen, and then the transaction synchronization is going to happen, and then the provider is going to write out to the database. And then it's going to get the ID. But what did we do? We returned the ID before the method was over, because we got it. But we don't know if the ID is actually there.
So at runtime, what would be happening here?
Well, it would be null. It could be null. Now, in actual fact, in most cases, it probably will be there, because most implementations are going to default to using, a table or a database sequence or something like that. If you're using, however, a SQL Server, for example, which uses identity, and I don't know if they have a sequence yet, but they didn't for a while, then basically you might not get any ID there, depending on the implementation. Implementations are free to do what they want. And if you're using deferred rights, which most implementations do, then you won't get one. And you know what? You probably don't want one. Because if you got one, that means they're doing an eager write. And they're going to start a transaction. And you probably don't always want an eager write that'll persist. Because that's going to start holding database locks. And your scalability is going to be affected. So, that's where flush comes in. Flush says, by the time I get here now, this is a portable way of causing that object to be written out. Because in this case, we might want it to be, if it's absolutely important that we return the ID from this account method, this create account method, then we really do want persist to write it out. So this guarantees that we have an ID always available by the time we reach this next line, because we've done the flush. So if we're writing to an identity column, then the object will be inserted and we'll get the ID back.
So I've just been in this kind of situation. I've just been returning the new entity object. And then doing get ID in the calling talk.
We could do
so
that
that's
too.
perfectly safe.
Yeah.
Okay.
Yeah. In this case, we weren't actually returning the account object from any of these methods. We were returning just data, some state of the ID. Now, if you're returning the account object, it is actually being managed here. So it's managed when you return it. But by the time the transaction commits at the end of the method, then it's no longer managed because the persistence context is closed. So the account comes out, and the client now gets a detached account.
That's good to know.
So you return a managed one, and it received it detached.
Okay.
That's what's happening. So that's what flushing is all about. It causes all the changes to be written in the persistence context out to the database. Means that all the inserts and deletes are going to happen then too. Any updates are going to happen. Callbacks, like a post-insert callback, is going to get triggered. Okay, that's when a flush will happen. So these are kind of some side effects. The transaction doesn't get affected. It still won't be committed. It's just saying write these changes out. The transaction will be there still. You can still roll it back if you want to. How do you read? Well, the find is the best way to read a single entity. And here's how you do it. Let's say we're getting the balance now. This is our get balance method. We pass in the account ID. We do a find on the account class, passing in the ID, and return the balance from that account. Now this is a great method, except that it could break, because it doesn't actually check to make sure I got the right account. In this case, the find method returns null if the account wasn't found. It doesn't throw an exception. We found that nulls are a lot easier to handle than exceptions, and so it's really a lot nicer to error check using nulls. So what we do is we allow you to check for null to see if the object was found, and then decide at that point. And I'm not checking this method. I'm assuming the account was found. So this one's kind of brittle, but it sure makes it for a shorter method.
Just to go back to the flush and persistence.
Flush.
Sorry.
That one or the one before?
Yeah, this thing.
Okay.
Both of them really. That means the persistent context, this hash map thing, that's not consistent. It doesn't have to be consistent because you could get like multiple methods doing stuff to the same object. Is that right?
It will be consistent. What's not consistent about it?
If you haven't called the flush.
If you haven't called it?
Yes.
Okay.
So while you're still calling persist.
Yes.
You could get, two methods changing the name to who knows what.
You can't persist is persisting a new object. So you can't persist the same new object. Once it's managed, then you change the object itself to make changes to it.
And then because multiple methods begin the same actual object.
Multiple methods.
If you had multiple transactions or multiple methods manipulating the same account object that wasn't a new one, that was coming out of the persistence context,
Yes.
it would be the same actual object?
Well, it depends. If you still have the persistence context open,
Yes.
and you're passing the same object out to different people,
Yeah.
then you're having multiple users concurrently accessing the same persistence context, which would be bad, because they're not meant to be concurrently accessed.
Right, that makes sense.
Yes.
But if you had session needs or something, they'd each have different. Say you had 3 servlets accessing the same account, they would each have different transactions.
They would each have different transactions, different persistence contexts. So they're totally isolated from each other. Yeah. So that would be fine. So here's how you modify it. I think this is something like what you were talking about, where you basically found it, and here you're modifying this. If you had 2 guys doing this at the same time, they each be finding their own inside their own persistence context, and they'd be changing it. Okay. But the idea here is the only thing you do is find to cause the object to be managed. Once you've read it into an entity manager, it gets managed in the persistence context. You just start changing the account. So here, this is our deposit operation, and all we have to do is look it up to manage it, and then change it. Return the new balance. And by the transaction end, those changes will be reflected in the database.
So where does the exception occur if 2 people are depositing at the same time?
Right? Okay, good question. So the exception, so the problem is if 2 people do it at the same time, they both take the same state out of the database, and there's 2 separate transactions. So they're both going to try to write. One guy's going to win and do the write. The other guy's then going to try it. And if you have an optimistic locking field to find your entity, then it will compare the optimistic locking field against the one that it read in and determine that, oh, it's overwriting some other data that has changed since it last read, and an optimistic lock exception will be thrown. So at transaction commit time, the optimistic lock exception will throw, and then you will have to retry your operation.
So this deposit method will throw an exception?
You'll throw an exception. Yeah.
and it's to uncheck.
Sorry?
It's a runtime one because we're not.
It's a runtime exception, absolutely. In fact, it won't even happen until the method ends, because the transaction will be, if it's a container managed transaction, which these are, then the transaction will commit at method termination time. And so you won't get a chance to even know about it here.
Not within this method.
The client will get it.
This method.
Exactly. So the servlet will actually, the web tier will find that exception happening.
But you could call the flush there.
Exactly, exactly. And that's what I was saying earlier on, saying that actually a flush, at the last point there, when you have a container managed transaction, the flush allows you the opportunity to handle that transaction inside your exact method. That's really one of the best uses for flush.
Or you could wrap it in an interceptor.
You could wrap it in an interceptor, and you could catch the transaction there.
You can use the same password for
You're already thinking of uses for interceptors. Very nice. So, unmanaged entities. What happens if you have someone, you've taken your account that you pass back to your client, and the client now wants to change it. Well, the client should be allowed to change it. It's just changing stuff in a browser or something, and then wants to send the changes back.
No one would guess that.
So here's where the merge comes into play. The merge takes your detached object and puts it in the persistence context. And the key here is to know that the object that gets returned when you update is not the same one you passed in. This one you pass in is detached. The one you return is managed. It has a different object identity than the one you passed in. So update account, this kind of update account method, actually returns, if it has a transaction around it, container managed transaction, it's going to take a detached object and pass back a different detached object, is what's going to happen. Because it's going to merge this, those changes will be committed, and then it'll return this exact instance that's merged, but by the time you get out of it, it'll be detached again, because the persistence context will be closed. But you don't care that it's a different detached instance. All you care about is your data gets merged. And finally, deleting, you do the same thing. You find the object so that it's managed. You want to get the balance before you delete it. Then you say remove to it. Return your balance that was in it, so that you return to the client how much they actually had. All right. Okay, so let's just go over object relational mapping a little bit. A little more to object relational mapping than what we first saw. We saw some basic columns, but I mean that's the basic mapping, is taking an attribute and mapping it to a column. We call that a basic mapping, and all the basic types can be mapped that way. So all the kinds of primitives and wrapper types and so forth, enumerate types even. If you want to override what the default is, then use this @column annotation. Relationship mappings come under one of the 4 basic flavors here, using different cardinalities on each side, and they can be unidirectional or bidirectional. In the bidirectional case, there's this notion of ownership that's involved. And the owner, the owning side of the relationship, is the entity that has the foreign key in its table. So we call that the owning relationship because it kind of is the one that kind of dictates what happens and how things get updated. That entity gets updated, and the foreign key will be updated in the database. So it kind of owns the relationship in that sense. The other side we call the inverse side. So the owning side, since it has a foreign key, it specifies the physical mapping of that foreign key to the database. And the join column is the equivalent of column for the mapping. This is for foreign keys. We call it the join column. A join table is used when you have a full join table or association table for mapping 2 entities together when they're many to many. So you can have a row representing each time that those 2 are joined. Okay, to show these kinds of more advanced things, we need a better entity map model. So we're not going to just have an account. We're going to add a couple more entities on and have a transaction, where there's a one-to-many from account to transaction, and a one-to-one between the account and the customer. Okay? Now we can have relationships. Yippee. We'll show you this model up in the corner so remember it. Being so complicated, it might be easy to forget. So here we have our new account. It's got now a bunch of transactions. And we're using a generic here to say that it's a list of transaction type. If you didn't have a generic and you didn't say that it was a type transaction, then you'd have to specify the type in the one-to-many annotation. Right? But here we see that we're using the default table name to account. Whoops. I guess I'll explain the rest. The generated value and ID we already know. The one-to-one mapping here says I have one-to-one to customer, and this is bidirectional. The foreign key is actually in the customer side. So it means I'm the inverse side. So what we do is we put this map by attribute in the one-to-one. And the ACCT, or the account property, is the property in customer that is the other side of the relationship. Okay, the customer is pointing back to the account, and it's pointing back in its account property to me. So this is the place where this relationship is being mapped. I'm not the owner, so I'm specifying where the owner is. And same thing goes for one-to-many. Whenever I have one-to-many, then there's a many-to-one back from transaction to me. And that account property in transaction is that many-to-one relationship back to me. So that's where the foreign key is going to be. That's where the join column and everything is going to be decided. So what I'm saying here is saying, I defer on these relationships. I'm not the owner. But I am related to this guy, and go see this person, this class, this attribute, to find out where to define all these things. Now notice in the list here, I'm also adding an order by here to say it's an ordered list. This tells which property of transaction I'm ordering by. So it'll actually order all of these in the query by transaction time of the transaction.
Can you specify
Ascending or descending, yes. By default it's ascending. There's a default. Most people want ascending, so we made that the default. You just specify, you put a space in there and put ASC or DESC for descending.
You mean the space after the TX time
That's correct.
before the end quote?
In the quote, yeah.
Like you do it in a query.
Exactly, yeah. And so I promised you that there was XML equivalents to all the annotations, and so I was going to show you that, just to prove that I wasn't lying. Now, you know, it's a little bit more verbose here because you've got to specify what the property name is, and you have all this extra stuff. But that's equivalent to all of the annotations you just saw. You could not annotate your class at all and put this XML in an XML file, the XML mapping file, and you'd be exactly equivalent. Let's go to the customer class. So we have the customer table. In this case, the last name points to the L name field, so we had to override last name with L name, and same with first name, we had to override it with F name. Address, just as using the default, going to address. And this is the other side of the one-to-one.
Everybody's at work, you know, with the old gas.
This is the one-to-one to account between customer and account. In account, we said we're not the owner, let's go see customer for that. It's under the account property. Well, this is the account property that's the other side of it. And it's actually not specifying any join column, although it has one. See, this join column points to the ID and account. But I'm not saying what the name of it is. But the default is supposed to be account, so what's wrong here? It's account ID. The reason why this is because the defaults are different for relationships. For relationships, you don't want it to be called account, the name of that, because it's a foreign key. The usual thing for foreign keys is to underscore the primary key that you're referring to. So the default for foreign keys here is we take the property name and we add an underscore, and then we add the name of the field, or the column rather, that it's referring to. So that's where you get account underscore ID.
Is that
this thing underscore that.
Is that a default part of the spec, or is it?
That's part of the spec. Yep, that's written right in the spec. These defaults are all written in the spec. There's the XML. We'll skip past those. Lastly, we have our transaction class. Here I'm overriding the name of the class. I'm calling it ACCT underscore TXN. And so that's not going to be just transaction. And I've also got a date, a Java util date class, and I have to specify whether it's the time or the date or the calendar I want. So I put temporal annotation, say it's really the time for the TX time. This will be the thing that I'm ordering my list on, right, on all the times of the transactions. Here I'm overriding, this is an enumerated field, and I'm saying that this is going to the op column, and the different values of that enumeration are going to be recorded in the op. Now I'm letting the defaults for mount ride here. This is going to mount. And this is the other side of that one-to-many between account and transaction. It's the many to one back. In this case, I am specifying the join column as account underscore ID. Here I've called it account, but I'm saying ACCT underscore ID as the join column name.
What? Oh, really?
What's the, because I noticed there's 3 temporal types, time, date, and timestamp.
Yeah.
In this, I assume time would just be a time and forget about the date completely. Is that correct? Or?
Yeah, it takes the, so you know how Java util date is this weird hierarchy of stuff, where it includes all of those things. So you have to specify which Java SQL type you're going to use to go to the
so
database.
If you want date and time, you need a timestamp.
Yeah.
Okay.
So shouldn't that be timestamp?
Yeah, I'm just wondering. It seems a bit weird to use time here.
You can also use time in the database, but you could, yeah, I could have used date and time if I wanted to. I probably would want to do that.
Yeah.
Yeah, let's do it.
Simple API that kind of allowed you to take one or the other and generate the other side. But it's really not a meet-in-the-middle mapping. In other words, you can't take a pre-existing object model and a pre-existing schema and map the two together. Right? JAXB doesn't do that, and so this allows that to happen. You can map it to a web service schema or anything else with a pre-existing Java model, which really helps. Plus, there's a database adapter when you bottom of it. So this Eclipse Link project is really something we're excited about because it takes TopLink to open source levels with all these 3 things. And I mean, for us, some of the real benefits of this are that you can take a JPA entity and then map it to XML schema at the same time, and write it out to a schema in one hand or write it out to a database on the other, all within the same runtime project. So, a summary. The EJB3 has introduced a bunch of stuff. Essentially, it's made it a lot easier. I mean, that's the main win of EJB3. It's allowed easier development, easier use, more features with interception. Java.net. There's whatever application server you use will more than likely have some site around it to give you some papers or information, stuff to use their own stuff. The Eclipse Link project has a URL. I think there's a code drop on there now if you're interested in committing or being a committer to Eclipse Link. Then by all means sign up. And of course, there's a good book that I can recommend if you want to know more about JPA. Actually, we've had good reports on this book. We're pretty proud of it, and it's been one of the better received JPA books.
So what about really advanced SQL stuff? Is there any way to integrate that? I mean, like derived tables and.
Yeah. So we.
Australia, Tasting Australia, we met the map.
What can I say about that?
Or is that something for native query or?
Yeah, native queries is the best way to integrate that. You can use aliasing and things like that, and then once you've aliased these things, then you can map what the results are to the entity that you want. That's sort of the best way, or just return raw data from it if that's what you feel.
Yeah.
We discourage native queries, but when you get to a certain level of database, then you almost have to use native queries.
I know that's one of my main problems with EJB2 was that I've seen people do some horrendous things just to try and match things up, and where I can write a query in 2 minutes that runs in 10 milliseconds, and their function takes 20 seconds to run.
Yeah.
Because they're getting everything into memory and.
No, I mean that's just a fact, right? When it comes down to it, sometimes the best approach and the fastest, and usually there's a few queries that can sort of 90-10 rule where 10% of the cost is in 3 or 4 methods, and if you can speed up those 3 or 4, I'm sorry, 90% of the cost is in 3 or 4 methods. If you get those 3 or 4 methods really fast, then you could speed up your application dramatically.
I think I always used to say, EJBs are great for when it comes to web screen management interface. Pull up a single object, edit it, save it. But when you're actually coming up with a complex page that combines lots of stuff from different entities, you were just better off using, going back to JPC, doing a query, because then it would be fast. It just wouldn't be fast enough.
Yeah.
But with what I see here, some of the things like you can actually do joins and create those new objects with that data that you can use. If that's fast, which I presume it is. I presume most of it is translated to SQL.
Yeah.
So it should be pretty fast.
Yeah, well, I mean, different translations, there might be different, so I guess different implementations can translate differently as well.
Yeah.
So you never guarantee anything, but that's the measure of how good implementation is how well it translates in SQL.
Yeah.
And how often, but yeah, that's pretty much the back door is using SQL directly, and
Because the last thing you want to do.
that's always an option. Sometimes that's the last option.
What will they do?
Anything else? Well, if you have any questions, or if you're interested in finding out more, or if you pull it down and start it up and have a question about something,